So that's the adapter plate all machined. The collet chuck fits on. It is not loose. All it remains now, I'll have a measure of these holes. Hopefully, I think it's going to be something like a 6mm that passes through these. Some button-headed 6mm, is to take it all off, find a spot where these 3 holes don't foul anything underneath. I'm sure there will be a spot, even if it's sort of there, that sort of thing. There will be a spot. And spot the hole through, drill and tap this plate, and bolt it to sandwich it on. Then comes the moment of truth. Put the clock in there and put it back up. What I will do, just thought this now, is, where is it, my little knocker. Where I've got my 0 on the lathe itself, come back maybe 1/4 inch and just give myself a centre pop, so that whenever I put it on, it always goes on with that centre pop lined up with a 0. So where am I now? I set it back up like this after drilling it, bolting it back. 3 M6 holes now. I'm going to increase the size of these bolts. The holes that they're passing through in this hardened plate are 6.5. I'm going to open them up to about 8.5, 9mm. I'm probably going to have to use a sharpened masonry drill for that and drill them through, and then increase these bolt sizes to 8mm to give me some proper strength to hold this in position and hold it back firmly. But that's another story. On my first attempt, I did exactly what I'm doing now, and found that I was getting about 6/700ths throw out front and back, what have you. But I was getting a different throw to the front to what I was getting on the back, which led me to believe that the back face that's clamping against my adapter plate was not square to the bore. So I'll show you a bit of footage of that. So I've been spending time chasing this error around and round and round in circles. I've got a 20mm test bar, hardened ground test bar, centres either end, and I know it's right. So I've set it up, clocked it in perfect in the 4-jaw, and it's running through the centre of the collet chuck with a 20mm collet in it. The collet chuck is locked to the bar and it's running in my rotating centre. And my back face is showing 400ths out, pushing 2 thou out. So it's got a thou a throw in it. From the high point to the low point is 2 thou. So, rightly or wrongly, I'm thinking the first thing I'm going to do is just skim that face on the back to be running true. Knowing that it's hard, I'm going to be doing it with the aluminium type tip, and I'm just going to gently tickle across this face and machine it so that I know it's true to, well, true to the bore, let's say flat to the bore. It's not going to affect my register at all. We'll see how we get on. So did you think I was going to actually turn the back face using the collet? No, of course not. And the reason being that the collet, if it had any inaccuracies where I had it mounted on the 20mm bar, would have been transferred to the outside. So I'm basically changing the reference point from which I would be machining the outside of this. So what I've done, got a slug of aluminium. I know it's too long and stuck it a long way, but I just didn't want to cut it off to waste the aluminium. Turned it to sort of 35.5 diameter. Then I set up the taper by clocking the bore of this when it was in the 4-jaw chuck and all clocked up. Clocked the angle onto my compound slide. Then used the compound slide at that angle. I centre drilled the end of this aluminium bar and machined a taper. I checked the taper with blue, with my chromator blue on the inside of this and rotated it and what have you to make sure that I had contact all the way along my aluminium, which I did. So I've cleaned it all out spotless, drilled and tapped the end of the bar, and then bolted it with a washer here to pull the chuck tight onto that taper. Then I've centre drilled the end of the bolt, and I've got it mounted just for rigidity on my centre because I am stuck out a long way. So now I know now that that bore is running concentric to the lathe because the taper was concentric to the lathe and I pulled it up on the taper. So if there are any discrepancies between the bore and the outside edges of this, they will now show up. So I ran a clock on this back face and it was actually running out about 5 to 6 hundredths, let's say 6 hundredths. So I got a new tip up, one of my aluminium tips, and I've just tickled across the back face of this. In fact, it does need a finishing cut, but again, this face actually seems to be harder than that bore was in there when I bored it out. But I'm just tickling across this face to true it up. So what I will then do is strip it all down again, remove any burrs, sharp edges, and put it back up, and then we'll have another look and see if I get better concentricity of the bore when it's mounted on the back plate. So I'm literally going nice and gently. There is a little dent in the one corner of this, it's been there since new. It's just passed over that. And it will start to knock and give me an intermittent cut again when I reach the bolt holes. Yeah, we're just entering the bolt hole area now. I'm taking such a small amount, it's difficult to see that I'm actually cutting, but I'm sure you can hear it. Just come into the back edge of the holes. And as you can hear, I've still got a slightly intermittent cut on the inner face, so it's going to take a little more. You can see that swarf is actually curling off red hot in places, and that's just over a thou cut. That carbide tip is going to be basically written off after this. So in all, I've only taken about 2.5 thou off this, so I'm more than happy that that register's still deep enough. And there we have it. I'm just clocking up that face just to make sure that I wasn't getting massive deflection or something like that. There is a tiny dent in the back of here, which was there from new. It is a hollow, but the clock is running dead on zero all the way round, and it does a little bump on that hollow. So I'm more than happy with that. I'll show you the mandrel now that I've taken the part off. Yeah, simply taper that matched in. It was all blued, I've cleaned it all off now. Draw bolt on the end. The washer was bigger than the hole, bigger than the 20.5 hole, and pulled the mandrel, or the ER32 collet chuck, tight onto the mandrel. This is running perfectly true because it was turned in situ on the centre as well. So when I pull the collet chuck up onto here, it can be nothing but true to the bore. The outside could be nothing but true to the bore. So once skimmed, I know that that back face will be true to the mean angle of that taper in the bore. Okay, so let's try it again and see what results we get. So I'm going to attempt to show you my final result. I've opened the holes up with M8s. I haven't got any M8 bolts. Well, I had one. Where is it? There, I've got one M8 bolt in and that's tight. I had to reuse some of the studs, but I will buy some M8 bolts of the right length, some nice high tensile ones. So if I start, I've marked 4 lines on the chuck for 4 positions. It's very difficult for me to highlight this without touching the clock. I'll have to get some of those yellow clocks, I think. The ones that don't glare quite so badly. Anyway, smack on the 40 there. 40 point, half a hundredth. 40 again. Yeah, between 40 and half a hundredth. Now that's right on the front edge. And I'll show you I'm not fudging this. As you can see, if I move away, it rises up, lowers down. I get the needle somewhere closer to where you can see it. I'm getting about half a hundredths on the front face. So if I wind back in now, just somewhere near halfway, I've gone to the end of the travel on the clock. Let's have a look. That's probably too close to the back. I'm nearly there. That's about the halfway mark. As you can see, still got travel on my clock. And yeah, all right, benefit of the doubt, I'll call it maybe a hundredth of a mil there. Can I get to the back? No, I'm running off the clock again. In fact, that's about right, that's about the back. And again, yeah, I've got about a hundredth there as well. Difficult for me to show you the clock accurately. So yeah, top, middle and bottom, all a hundredth of a millimetre. I can't really get any better than that. That's, as you know, without grinding the bore, so to speak, to make sure that it is actually cylindrical. So yeah, I've got the chuck to within a hundredth of a millimetre. So we'll give the collet a fighting chance. 12mm cutter, and it's right through the back of the collet. So I'm not holding on the end 6mm, anything like that. Right through the back of the collet. Well, I suppose it says it all really. 5/100ths. 2 thou. And if I just come a bit further out, yeah, it's still 2 thou. So at least I know I got it parallel, and that particular collet, take away, you know, a couple of hundredths maybe, give it the benefit of the doubt, is running at least 0.03 out. That particular collet. If I said my chuck is running out 0.02, which it's not, but we'll give it the benefit of the doubt, 0.02. This collet is 0.03 out again from that. Now that's the case with this one. I've tried the 8mm on an 8mm dowel, very similar story, and I've tried the 20mm one on my 20mm rod. In fact, I'll put the 20mm one up and show you that. In 20mm collet, again, a 20mm collet, a piece of 20mm, I think the Americans call it drill rod, we call it silver steel. It is ground to size, and it is a brand new piece, a complete piece, 13 inches long. Okay, again, I don't know whether you can pick that up, 5/100ths, 2 thou. If I come out to the end, even worse. Now, I know I've got 100th front to back. If I clock it at the back of the taper, 100th, clock it at the front, 100th. If I'm half a hundredth out, that's it. Over, what, the 25mm? So, you know, I would expect a difference if I'm out by that much of a hundredth. Well, I've actually got 4 thou at that point. So the only place where this 20 mil is accurate, or not, well, accurate within 2 thou, would be right up at the chuck face. Yeah, back to 2 thou, 500ths. So all in all, cheap collets, I think it boils down to. I've been fighting my own backside for 2 days, playing about with this, trying to get the collet chuck running as accurately as I can possibly get it without grinding the bore. I haven't got a tool post grinder, but that would be another way of doing it. But the collets I got, more than likely made in China. Everything's clean in there, and you know, the best I can hope for is 2 thou. So yeah, there you go. I think I will be investing in a few collets of the sizes I use in little production jobs, which is the reason I bought the collet chuck. And I'll be buying some quality collets for the specific sizes I need, and keeping these ones for worst. I'll get a couple of collets for best, Sunday best collets, and these are all day everyday collets. I'll go through the lot of them, take down some readings, and see how I get on at a later date. But yeah, I suppose, bought cheap collets, no name collets, what do you expect? Just as a little footnote on this project, I've got no way other than putting a spanner on one of these nuts of undoing the collet. I can't stop the head moving when I'm undoing and doing up the collet. So I think what I'll do is pick appropriate spot, take the head off and what have you, and put in some holes, perhaps 10 diameter, something like that, you know, sort of 10 mil diameter, 15 deep, so I can get a Tommy bar into the hole, bring it down against the bed, perhaps a piece of, you know, something to protect the Tommy bar from hitting the bed or what have you, a piece of hose pipe up it, or something along those lines, something turned, maybe out of a bit of silver steel, so that I can hold the head while I'm undoing and doing up the chuck. Yeah, anyway, that's another one. So, you know, perhaps I'll put 4 holes or 3 holes in it in various places, wherever I can pick, so I'm not fouling my tapped holes and what have you. There are other holes in this, but yeah, certainly going to need 1 hole in it so that I can hold the chuck solid while I'm undoing and doing up the collar sleeve. So moving on from the collet holder, I also have my MT3 to ER32 collet holder, which I plan to use on a possible future milling machine. Let's just check that out, see if it is as standard. Anyway, so let's give it the benefit of the doubt. We'll zoom in. Hopefully you can see that clock fairly well. If I put my hand there, see what I can do. Now I've got the winding handle on the back of the lathe, so I'm not influencing the spindle at all. Oh, hang on. Should we try that again without dropping the spanner? Okay, so the spindle on that lathe, or the Morse taper inside the spindle of the lathe, I mean, I've been back and forth a few times, gone in deeper and what have you, but 1/100th is all I'm seeing, and that could be just me influencing the lathe and what have you, but yeah, 1/100th. So, I take away the clock, and I've made sure everything is absolutely spotless here. I'll fit the collet holder with a drawbar. Let's have a quick shufty at the outside first. Well, 4 to 500ths, so 2 thou out on the OD before we even start. So this doesn't bode well for a good result before we even go anywhere, really. But the outside doesn't actually do anything in relation to the bore, so let's check the bore. I'm about 4 mil from the back of the taper, and there I have 400ths. So at the front, let's give you about 600ths. Well, that's worse than useless as well. So back in with a 12 mil diameter milling cutter, tightened up, and yeah, 500ths, 2 thou run out. So I know I had tooth thou run out with this collet in my proper collet chuck. So probably the orientation of the collet within this chuck, which is throwing tooth thou out, I've probably split the difference. And by rotating the collet within the chuck, with the collet being eccentric by tooth thou, I could probably tune it in, so to speak. But you can't do that every time you're going to put something in the collet. Defeats the object. So I think, again, a Sunday best collet would improve the use of this, and probably grinding the bore concentric to the MT3 would help as well. I may look into a tool post grinder, we'll see, or maybe making's a light duty tool post grinder, you know, that's going to be able to take a thou out of hardened steel, that sort of thing. We'll see. So to wind up this little project, conclusion, I think with the collet chuck itself, success. Need to get some 8mm bolts and to drill a couple of holes in the back. But within a hundredth, success. The MT3 version, pretty much worse than useless. It's going to need grinding in the bore to make it concentric to the MT3, to make it, you know, properly useful. Best thing about that set was the spanner's good. And the little box that the collet came in, well, that's sweet enough. The collet's come in, that's sweet enough. So these are work a day, let's say, accurate to within about 3 thou collets, as long as they're not too far out from the chuck. Exactly the same with the MT3. You know, it is what it is. It's not that accurate. If I were to buy a couple of quality collets, basically, where would I want it? 6mm, 8, 6, 8, 10, 12, something like that. 4 collets, I'll have to buy decent quality ones, known brand, that sort of thing. If anyone's got any suggestions of which ones to go for, comments below. You know, that aren't 30 quid each, you know, that sort of what's it, you know, but good collets that you've tried, tested, and you know that they're quality for a budget price for a man in the shed, then yeah, comment below. So all in all, happy with the work I've done. Not happy with the purchases I made. Well, we live and learn. I'm not the first one to come across this, and I'm sure I won't be the last. So, collets themselves, you can always fudge the collet holders and what have you, and bugger about and get it to run true, one way or another. But the collets, you know, to make a set of collets, forget it, forget it. So, yeah, my advice to anyone would be, if you can afford it, buy the best you can afford. Saves a lot of time and hassle, but it can be done to make the holder work efficiently. But the collets themselves, the cheap collets, unless you're doing it on recommendation, don't buy the cheap collets. They weren't cheap. The spanner, the collet set, and the MT3, all as a set, came in about 140 quid. I deliberately didn't buy the Banggood ones, which would have been that set for about 75 quid. Thinking, let's go for better quality. More fool me. Right. So, yeah, that pretty much concludes it. I do hope you've enjoyed this little excursion into the realms of ER32 setups. It has been an adventure for me. I've had to have several cups of coffee and walk away from it on several occasions and come back. Made a few mistakes along the way. Changed my mind a lot along the way. But I got there in the end, and that's all that matters. So anyway, if you haven't subscribed already, please push that subscribe button, guys. It means a lot to me. Feel free to comment below on this little project, for good or for bad. And thanks for watching, guys.